So in this video, we're going to be talking about exponents. This probably is a little bit of review for you, but we're going to go through it anyway. Instead of writing 9 times 9 times 9 times 9 times 9 times 9 times 9, it gets a little bit aggravating. We use exponents and we can write it as 9 to the 1, 2, 3, 4, 5, 6 power instead. And what I just did is I just simplified things. It's just easier to write 9 to the 6 versus 9 times 9 times 9 times 9 times 9 times 9 times 9. I think I said that right. Anyway, that's really all exponents are, is taking something complicated like this and simplifying it. So let's just break down what this really means. So here I have a number here. This number right here is what we call the base. And I'll give you the definition. It's the number we are multiplying, okay? That's it. It's the number. We're going to use the number 5. And the 6 is what we call the exponent. And the exponent is simply this. It's how many times we are multiplying. And I'm going to put the base, all right? All about the base, okay? So that's all this is. The base is the number we're multiplying, and the exponent is how many times we are doing the multiplication, how many times we are multiplying the base. And lastly, this whole thing, we kind of call it a power. All right, so this is 5 to the power of 6. And that's how we read it. So this right here would be written as 5 to the power of 6. That's one way we can write it, 5 to the power of 6. Or we can write it as 5 to the 6th power. It's all basically the same thing. All right, so it's really not that hard and complicated. As long as you understand that when I go to write this, I'm really going to be saying 5 times 5 times 5 times 5 times 5 times 5. 1, 2, 3, 4, 5, 6. So I'm multiplying 5 by itself 6 times. All right, now let's just move on to some of these problems here. Okay, so first off, it says write the product using exponents. This is pretty simple. I have 4 times 4 times 4 times 4 times 4. So since I know that I'm multiplying 4, that is my base. That's easy. And how many times did I do it? 1, 2, 3, 4, 5. So this right here would be 4 to the 5th. Now let's look at this one. I am multiplying negative 1/8. Notice how this is in parentheses. This is a big deal later on, and we'll talk about that in a minute. And I'm multiplying negative 1/8 times negative 1/8 times negative 1/8. Well, since all three of these are the same, I'm going to write negative 1/8. And I'm going to put it in parentheses. And how many times did I multiply it by? 3. Okay? Now, this one, oh no, this looks mighty complicated. Not too much. I have a couple of 5s and I have a bunch of negative x's. So let's start with just the 5s. So this would be 5, and it's being multiplied by 2 times. So it's 5 squared, or 5 to the 2nd power. Now let's look at this one. I have 4 negative x's. So I'm going to write negative x as my base. And how many times did I multiply it? I multiplied it by a total of 4 times. So I rewrote this very simple. Now, you could have put a little multiplication sign in there if you wanted to, but it's not necessary. When we have numbers like this and letters beside each other, as you are already aware of, it's pretty much multiplication. So I have 5 squared times negative x all to the 4th, okay? So why don't you try 9 by yourself? What you should have gotten was 9 squared y to the 6, okay? Now look at this. It says evaluate the expression. So when I say evaluate, I'm telling you to solve it. I'm telling you to tell me what it really means, to give me an answer. So to evaluate this expression, I have 10, and it's being multiplied by itself 3 times. So 10 times 10 times 10. I work this out, I get 1,000, okay? Now, this next one, I'm going to talk about, no, I'm not going to talk about it just yet. I want you to try these next 2 on your own first, and then I'm going to talk about the proper answers. So for number 6, you probably did this. Negative 7 times negative 7 times negative 7 times negative 7. And when we go to solve for this, and we're doing this without a calculator, I know that these two right here, negative 7 times negative 7 is 49. And I know that this is also 49. And then I can work this all the way out, and I can work it on the side with some scratch work, but for the sake of time, I find out that it's 2,401, okay? And if you did this, you did it correctly. Now, this is the one that may have got you. This might be what you did. You may have went negative 1/6 times negative 1/6 times negative 1/6 times negative 1/6 times negative 1/6. This may be what you did. Now, if you did that, you did so incorrectly. And here's the reason why. This is not correct if you did that method. I want you to look at this number again. Notice that I have a negative on the outside of the parentheses, whereas in this case, I had it on the inside of the parentheses. Well, what does that mean? It means that that negative is not being affected by this exponent. The exponent is only affecting what's inside the parentheses. So that negative is by itself. So what we really have is 1/6 times 1/6 times 1/6 times 1/6 times 1/6. Is that 5? 1, 2, 3, 4, 5. Yes. And then when we work that out, I'm going to be lazy. I'm actually going to use the calculator this time. I find out that this is going to give me 1 times 1 times 1 times 1 times 1, because we're multiplying fractions. We go across the top, gives me 1. And when I go across the bottom, I have 7776 is my fraction here. And now don't forget that negative was on the outside the whole time, so we actually have to put it back. So the answer to this is actually going to be negative 1 over 7,776. Wow, that's pretty insane. So the moral of this story is when you get an exponent, it only affects the number that it's directly connected to. It's not connected to this negative. Before I move on to these next ones, let's give you just another little example here. And I'm actually going to kind of write this as a number 8 on your paper. So if I give you something like this, negative 4 squared, keep it really easy. Notice that the only thing that's being affected here is the 4. It's not affecting the negative. So the answer to this is actually a negative, and then I'm going to go 4 times 4, which gives me negative 16. However, if I wrote this, what's being affected by this 2? It's the negative 4 as a whole. So I can write it as negative 4 times negative 4 and get a positive 16. So just be aware, this is something that catches a lot of people all the time. I'm going to say it, I've said it before, and I'll say it again to every person I meet. Negatives will catch you. They will harm you if you are not watching them. All right, so let's move on. Okay, so I'm going to give you a little bit of a challenge problem here. You kind of know the basics and ideas of how exponents work. Why don't you try 8 and 9 on your own? I'm not going to talk about them just yet. Remember your rules for order of operations. Please excuse my dear Aunt Sally. Please excuse my dear Aunt Sally. She walks from left to right. So remember those. All right, so number 8. Let's zoom in just a little bit here. So number 8, please excuse my dear Aunt Sally. Always look for your parentheses. So parentheses, do I have it? I do have them, but is there anything inside of this parentheses that I can do? Well, no, not really. Next thing, exponents. Well, the exponent's right here. So it's telling me to multiply negative 5 by itself 2 times, which is what I do. So I'm doing that next. When I do, I get 25. Now I have 3 plus 6 times 25. So let's follow my next one after exponents is multiplication and division. Well, what I have is 6 times 25. That gives me 150. And last is to do my addition and subtraction, which when I do my addition here, I get 153, okay? Now this next one's a little bit more complicated because there's a lot of moving parts in here, so let's discuss it for just a second. First off, notice that I have absolute value signs here, okay? So I have an absolute value sign here, and I also have some parentheses, and I have exponents. So please excuse my dear Aunt Sally. Well, parentheses also follows under not exponents, but the absolute value sign. So we need to work everything inside of this absolute value first. But before I can even do that, I have to work everything inside this set of parentheses then, okay? Now that I know that I'm working with this set of numbers, 1 to the 10th plus 9 minus 2 to the 3rd, my job is to work with these three sets and do exponents. Well, this one says 1 to the 10th. Well, this is easy. I don't have to even write this out, but this is saying 1 times 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 1. I think that was 10. I don't know. I may have miscounted. Doesn't matter. But anyway, what's 1 times 1? It's 1. So 1 to the 10th power is simply 1. That's easy. Then we do the next exponent. Now look, you may have put something different. Notice that this 3, this exponent, only affects the 2. It does not affect the negative, so I'm only going to go 2 to the 3rd power, which I know to be 2 times 2 times 2. Okay, and what's that give me? Well, it gives me 8. And since that minus sign was there, it stays there because it was not affected by this exponent. So now I have 1 plus 9 minus 8. Now I need to finish out my inside of this parentheses. Well, what's 1 plus 9? That's 10. Take away 8 gives me 2. Now I have a fraction, negative 1/3 times 2. Well, how do I multiply these two things? Well, let's just do a little scrap work over here. I have negative 1/3, and I'm multiplying it by the whole number 2. Remember, when working with fractions, it's best to go ahead and change it all into fractions. So I have a whole number. Let's change it to a simple fraction. In this case, it would be 2/1. Now that I know I'm multiplying, I multiply like normal. Negative 1 times 2 gives me negative 2. 3 times 1 gives me 3. So altogether, negative 1/3 times 2/1 gives me negative 2/3. Now, don't stop here. Notice that this is the absolute value. What does that mean? I'm trying to find how far is negative 2/3 away from the number 0. I'm asking for the absolute value. When I do, I get just 2/3. So this is my answer. This problem had a lot of moving parts in it, and I actually really like that. So I'm actually going to give you just another one just so you could experience it on camera. Let me see here. Let's do this. I'm going to write it on here. So this actually needs to be on a side piece of paper. And we're going to call this, we'll call this problem 11 for now, okay? So problem 11, this is one that needs to be in. Matter of fact, I'm probably going to ask for this. Just be aware of it. So I have 1/2, and I'm going to multiply all this by 4/3 minus 6 times 3 square parentheses, and all of this is I'm getting the absolute value of it. So again, let's work this out step by step. Parentheses, we're going to work all inside. So let's do our exponents. I have 4 to the 3rd power. Let's do some scrap work. I know that that's going to be 4 times 4 times 4. Well, 4 times 4 gives me 16. I'm going to multiply that again by that last 4. I get 6 times 4 is 24. Carry the 2. 4 times 1 is 4. So this will be 64. Okay, so we know that this is 64 minus 6, and then this right here is a multiplication of 3 square. Well, with that being the case, 3 square gives me 9 because 3 times 3 is 9. All right, now I've done that. My job is to go ahead and continue working inside the parentheses, following my PEMDAS rules. And I notice that my next thing I have is multiplication here. So let's finish it out. We have 1/2, and then this would be 64. Well, what's 6 times 9? That's 54. So we will put 54, all in parentheses. My job now is to continue to work. I'm still working inside this parentheses. What's 64 minus 54? That's going to give me 1/2 times 10. Well, what's 1/2 times 10? Well, this one's a very simple one. You should be able to ask yourself, well, what's half of 10? Half of 10 is simply 5. Okay? And now that I want to know what I have 5, what's my absolute value of 5? Well, it is 5. So that's my final answer. Notice what I did. I worked from the inside all the way out. All right, so I'm going to leave you with question number 10 as your, what's the word I'm looking for? I can't even think of the word I'm looking for. I'm just going to leave question 10 to you. And this says, a foam toy is 2 inches wide. It doubles in size for every minute it is in water. Write an expression for the width of the toy after 5 minutes. What is the width of after 5 minutes? So try this one on your own, and I will see you in the next video. Bye-bye.